everyone. In this video, I am going to solve a problem from differentiation of interfirst year. Question is, function is given. For that function, we have to find the derivative using the first principle. First of all, what is the first principle? First principle is limit h tends to 0, f of x plus h minus f of x by h. This is the first principle. This is the first principle. Now using this we have to find the derivative of sine 2x. Okay. So f of x is equals to sine 2x. Okay. Then what will be the sine of x, f of x plus h? Sine 2 into x plus h. This is equals to sine 2x plus 2h. Okay. Now using this we have to write this. Limit h tends to 0. F of x plus h is this one. That is sine 2x plus 2h minus f of x is the first function we have taken. That is sine 2x whole by h. Okay. Then here we have to use one trigonometric formula. Here it is, if you take 2x plus 2h as c and 2x as d, sine c minus sine d is equals to 2 cos c plus d by 2 sine c minus d by 2. Okay, this is the trigonometric formula we have to use here. So here c is what? 2x plus 2h, and what is d? 2x. Using this we have to write this first term in this limits first term. So limit h tends to 0. This first one can be written using this, that is 2 cos 2x plus 2h plus 2x by 2 sine 2x plus 2h minus 2x whole by 2 minus sine 2x whole by h. Okay. Now, sorry, for this only we have written this, right? This is sine c minus sine d. Sine c minus sine d, formula 2 cos c plus d by 2 sine c minus d by 2. So, now what you will get here? Limit h tends to 0 to cos of 2x plus 2x is 4x plus 2h whole by 2 into sine 2x cancel, what left? 2h by 2 whole by h. Okay. Here if you observe these two get cancelled, and here you can take 2 common. Limit h tends to 0 to cos 2x plus h by 2 sine h whole by h. Okay. So that implies what you will get? Limit h tends to 0. This two cancel, and what left? 2 cos 2x plus h into sine h whole by h. We can write this as, how to write? That equals to limit h tends to 0. Separate this. 2 cos 2x plus h sine h by h. Can we write in this way? This one we can write now. Here you multiply, you will get this h in this denominator also. That's why we separated like this. Okay. Next step. Okay. Next step, what? We have to remove this limit h tends to 0 and substitute h values there. Otherwise, here for this, if you use the limit h tends to 0, this becomes 1. Okay, why that becomes 1? Why that becomes 1 means, then you have to take separately using L Hospital's rule. If we do this using limits and derivatives, we will get here 1. Okay. So, for this, what we will get here? Limit h tends to 0 means substitute 0 in that. Before that, limit h tends to 0. Sorry. Limit h tends to 0 sin h by h. Here using L Hospital rule, L Hospital rule here we will use. What is that? A limit h tends to 0. We have to find for this d by dx of sin h by d by dx of h. If you do d by dx of sin h, sorry, d by dh, this what you will get? Cos h, limit h tends to 0, cos h by d by dh of h ante then 1. So here substitute the, in the place of 0, h, in the place of h you substitute 0. What you will get? Cos of 0 is equals to 1. So the value of limit h tends to 0 sin h by h is equals to 1. Okay. So for this we got 1. So that implies limit h tends to 0. No need of writing this. 2 cos 2x plus 0 into 1. This is 1, right? I did the proof here. That implies 2 cos 2x. That is the answer for the derivative of sin 2x using first principle. Okay.